Now I'd like to turn to Jim Murphy, who is building the LaBelle Business Car in HO scale. Jim, welcome.
Tonight we're going to move on to episode 5, interior lighting and marker lights. This is above and beyond the basic kit, but if you're going to put this much effort into building a model you can really be proud of, it's taking it to the next level. And this is for the benefit both for new modelers and for some older modelers who need to be aware of some new techniques that make marry electronics into the to the caves. First thing we want to do is take some trucks. We're going to have to bring electricity from the rails up into our model. I decided to use an old pair of Central Valley trucks, which after 50 years are still some of the finest ever made, and clean off the old wheels. Then we have to add electrical pickups. This is a phosphor bronze wire with wires soldered to it. These wires are short, flexible, and they will bring the juice from the rails through the wheels up into it. And to make sure I get no flickering, every wheel will be an electrical pickup. Notice that some wheels are insulated. They have the insulated marks on them here. The other side are not insulated, meaning the axles can pick up juice as well as the frames. I put a little dot of paint on them to remember which is which. I want the insulated wheels on one side of the car and the non-insulated wheels on the opposite side of the car to avoid any potential for shorts. The way it works, taking power off the rails, I'll start with a simple case of putting DC on the rails. I pick up the plus and minus from each side of the wheels. I then put it through a rectifier. This allows either side, whether it's plus or minus coming in, is converted to DC power at the same voltage. In other words, it comes out this terminal on the rectifier. That I put a white dot on that so I know which is plus. I put the plus to my LED, and I'm going to be using LEDs exclusively now, no more incandescent bulbs. Go out on the negative side through a resistor, which limits the current through the LED. If I put any more than 3.3 volts through that LED, it goes poof, and that's no more like a flash bulb, no more LED. So you have to limit the current or reduce the voltage whenever you're using an LED. In this case, I first reverse the polarity so it's correct, and then limit the current with a resistor. When I polished the rails with that Dremel wheel, it was not enough. I found even on the test track, I couldn't get good conductivity. I took a 600 grit emery board and then applied just some long strokes on that. And the difference between a polished wheel and a really polished wheel, you can see the difference. That 600 grit really did a difference, and I was getting excellent electrical pickup from each wheel because I polished the wheels. Now I have to have a way of bringing the power from the wheels up to into the car body. Fortunately, early 1900s cars used truss rods, which for my purposes is a perfect electrical bus bar running down the length of the car. So instead of using the wire supplied, I used 20 thousandths phosphor bronze wire from Tichy, and that is going to become my truss rods. Notice that I have no top detail on the floor yet. I've got to be able to turn this car upside down, work from the bottom, and then bring the electricity as well as finish the detailing. I started the detailing. The truss rods are in place. This particular kit uses die-cast queen posts, which of course are metal. So if I had metal queen posts all the way through, I would have a dead short before I got very far. So once the queen posts were epoxied in place, I took a Dremel, cut a small slot in each queen post, filled it with some squadron putty, and then the next paint job will cover it over. So the left side is electrically isolated from the right side. The truss rods come up through the bottom. I left a good 1/4 inch or more coming up through the bottom of the floor. It not only holds the truss rods in place, but it also gives you a place to tie in your electrical contact. The next step is to eliminate resistors. In the previous slide, we saw that every LED needs a resistor if you're going to put more than 3.3 volts on it. So that's, I'm probably going to have 10 LEDs. That's 10 resistors. That's 20 solder joints I don't need to make. So I'm going to eliminate resistors by providing 3.3 volts. This circuit uses the rectifier we talked about earlier. Here's a part number. The rectifier provides the same voltage as the track, only in DC. This will always be plus, this will always be minus, whichever one we have. I then put it through what's a linear buck voltage reducer. This takes whatever voltage you put in up to maybe 20 volts and knocks it down to 3.3 volts. There's the part number for it. It's rated at 1 amp. It produces 3.3 volts, no matter how much DC power you put into it. And rectifier takes anything from AC, like Lionel or DCC, variable square wave AC, to straight DC, converts it to DC with the controlled polarity, and then that is further knocked down to an exact output voltage, and you can run a 3.3 volt LED without any resistors. And at a 1 amp rating, you could probably put 30 LEDs coming off this one tiny component. I'm going to provide a schematic of this circuit along with the listing of these components that go into it, the electronics there. If somebody could put my email address up in the chat, just send me an email and I'll be glad to send you the schematic as well as a parts list, so that with any input voltage on the tracks, you can get 3.3 volts out for your LED usage. Here's it again. I said they're not expensive. The rectifier is 65 cents. The voltage regulators 79 cents in quantities of 10 each. Dirt cheap from Digitrax or Mouse or wherever. Here again, there's a blow up of it. When you actually want to save some space, these are tiny, tiny components. So I just close couple them, solder them up close together, and they'll fit in a pretty darn small area, so they don't take up any room from interior detailing. Here it is hooked up to the trucks for testing purposes. Again, the trucks, power coming in, rectifier changes it to ZCC. The voltage regulator knocks it down to the voltage you want to use for LEDs. And just keep remembering what's plus, what's minus. In this case, blue's plus, yellow's minus. Keep that in mind as we get along. Yes, I messed up somewhere along the way and forgot what color was which. Now, the LEDs we're going to power. These are 0402 LEDs, and that's my fingertip. And these guys are incredibly tiny. You may think it's a challenge for older eyes. I'm getting up there in years, but I have eye loop, I have a magnifier, and I have an old-fashioned visor with 5-power magnification. And yes, I can see these. Our purpose is to bring a string of lights inside a passenger car. Years ago, I wrote an article about how to use multiple LEDs. I think I used the 3mm LEDs, a ton of resistors, a voltage regulator. I had a rectifier in there, and it took up half the car still. Our purpose here is to be able to use some of this new technology and reduce the size of our lighting and increase the light output. You'll be surprised how bright these little guys just are. Here, all the components I need for this lighting bar are some 10 thou phosphor bronze wire. I like it just because it's stiff enough to work with to make a light fixture. And it's very easy to solder to these tiny LEDs. As soon as you take the LEDs out of this container, they go everywhere. They are tiny. They're 0.4 of a millimeter long. What this is double stick tape. I happen to use poster tape. Before you even open the package, get this poster tape down so that your LEDs land on sticky tape. And I'll be using this all through the assembly of the lighting bar. Here they are, getting ready for soldering. They're about 1 inch apart. This is solder paste. It's available from DigiKey and a few other mail order houses. It includes liquid solder or fine powdered solder and flux all in one. Very easy to work with, and it's used for surface mount components, which these LEDs are. Spacing about 1 inch apart. Here it starts to make maybe a little sense. The LED face down, a dab of this solder paste on the back, and there's the tube of solder paste. Well, we're talking about pretty small components, but if you use a magnifier, you can see it as well as I can with my camera. Start pulling them together. This is again on the sticky tape. I made them about 1 inch apart, and I solder one side all together. In this case, the positive side all gets soldered together at once. And the reason I do this is so I can check and check and check. This is one of the LEDs turned on the backside, which it's lighting side up right here. These are all being soldered in the downhand side with the lights facing downward. I build a string as long as I want to go the length of the passenger car. The way to tell the difference, look very close. One side of the LED on the pad has a minus sign on it. That's the negative side. The other side has no sign. That's the positive side. So what I've done is I've soldered the positive side of the wire all along 1 inch apart, and do each one of those. It takes a little manual dexterity, but once you've start going, it's just an assembly line. Just keep one after the other. Do all the positives together and then check them. I've got a positive wire here. Use an LED tester. This particular one is from an outfit called Microlumina LLC. Microlumina is on the internet. And it takes a 9-volt battery and it knocks it down to current limiting so you can directly test an LED. I put one wire under the common positive. The other one, I gently touch the negative side to each LED while it's still under assembly. That says I've got a good solder joint on the positive side and that each LED works. Here again is a 5-ounce tube. It's a few bucks for that solder paste, but there are applications when it's just nothing else will do the job. To put the negative wire along the same side, I use masking tape to hold everything in place. Put a dot of solder paste on each negative side. Do it one at a time and test it, test it, test it. Every time I make a solder joint, I test it just in case, and I've made some mistakes along the way. So test every time you make a solder joint. When they're all soldered, you turn it over on the front side, and you can see the amount of light that you get out of that. And that's just 3.3 volts on top of that. And I have a light bar that's going to light up my passenger car interior. And also, because it's so tiny, it doesn't hide the interior detail. Going back to the outside, I'm going to assure myself that I've got power. And the way I do that is I bring power from the trucks at whatever it is, 14 volts DCC, AC, whatever my power source is from the rails. And now I'm going to put that into my truss rods, which cleverly enough is an electrical bus. Wire each flexible truck wire right to the DCC bus, in this case, the truss rods, and do it fine. Again, I put a little solder paste on this, put a fine flexible wire on it, scrape the paint away first, and I can always repaint it. That gets power from the rail to the wheels to the pickups to the truss rods. So now I've got my track voltage all the way up inside to the truss rods, which go to the inside of the car. A little bit of paint covers all your sins. Nobody's ever going to know they're there. Notice I put a loop on them so this flexible wire remains so that I can turn the trucks easily with no resistance, no binding. Anyway, soft, flexible wire, multi-stranded to connect to the trucks. When I come up through the floor, you can see the little stub here from the truss rod, comes right up through the floor on both sides. I like to use, this is something I discovered working on structures. It's flat, 1/4 inch wide copper foil. It's adhesive on one side, and it's wonderful running around through buildings. Doesn't make unsightly wires. You can run it under flooring. You can run it from the top. It's adhesive on one side and very solderable on the other side. Just goes everywhere and takes the place of wire. It's only a couple of thousandths thick, just disappears underneath anything else. I put one strip down on one side pickup from the truss rods, put the other side down, make sure there's a gap between them so they don't touch, and then test. Here I've got 9 volts on the rails from my little battery pack here. Check it, make sure that you've got 9 volts approximately from your master, but check those two, because this is now my power pickup. So I've taken it from the rails all the way up to the inside of the car. On the inside of the car, I've got my rectifier and voltage regulator. Again, these are surface mount components, so I just have a dot of solder, and this can be regular old thin solder, doesn't take much. And this is adhesive, so it's going to stay put. I put a drop of glue behind the rectifier. It's there forever. And you notice the footprint is very small, so I can hide this inside the car easily and still continue on with the detailing. I bring a variable frequency in here. I convert it to DC. DC goes to the voltage regulator. I knock it down to 3.3 volts, and I put my voltmeter on that with power on it, and magically I am down at 3.3 volts, not to exceed. I can run my LEDs directly off of this circuit. Bringing that up, I got to hide this a little bit, so I made a vestibule for the back of the car. It's just a long hallway, and because it's so small, I can put a scene on the back side here. One side's going to be a kitchen, the other side's going to be a bar, but I just have to put a wall in here. I can drop this in there. Looking at it from the inside, it becomes a hallway and hides all the electrical components. There, everyone's times. Once you've got the bottom of the car worked on, it's time to go back and think about railings that are mounted to the floor of the car. In this case, I paint them separately, then cut them off with a Dremel so that they're ready to fit on the back of the car. If I tried to work around these railings mounted, I would have busted them into small pieces. So once this is in place, this is just pressure sensitive adhesive to hold my hallway in place. That protects the end rails as I go on to the next phase. So I start putting in the end rails. The one reason one is a little bit longer in the middle is so I can drill a hole and put something down in here because these railings want to have a wire pin holding them in place as they're gluing. Put them in place, touch up the paint a little bit. Again, one of these is drilled down into it, hold everything in place, and then set the railings in. So I've got the railings all mounted over here. Here's my vestibule. I've taken this assembly. That's the LED lights running the length of the car. And because I wanted to mount them up a little bit higher so they'd be in the clearstory, I put a little spacer block in here. Always remember at this point to label plus and minus. You cannot forget everything on this side's got to be plus. Everything on this side's got to be minus, or they won't work. I've also got loose wires here that I'm going to add for the marker lights. By putting the marker lights in the car body and putting the light fixture now, light bar, in the car body, that can travel separately and it's independent of the power pickups. We'll get to these later. Another shot there showing the all the wires there, and the beauty of these flat strips, these things, they're available also from Micro Mark. It's flat copper strip. Very handy stuff to have around. But again, everything is completely separated. The roof is loose, the car body's loose, and the car floor is separate. Now I've got them all together there, ready for assembly. Just put a little coat of paint on them to cover up the sins of the soldering. Touch up my railings, make sure they're right, and I'm ready to assemble the car. It's all set to go in place. And then I'll back up just a bit. When it's all assembled, these wires, the plus and the minus, will be soldered to wires up here, which are plus and minus. I left some sticking out. So all I have to do is do a little last minute soldering, and they could even be on quick connects if I wanted to get fancy. But to join the car, put the car body over the floor, 2 solder joints, put it on the rails, and you have an illuminated car that's got all 7 or 8 LEDs in the top. And as you can see, it's very, very bright. Also, the LED marker lights that are coming off that same bus bar are lighting that up as well. So we are ready to roll. This can go down the side. So our last thing, now that we can see inside the car, is going to be let it roll down the road or finish off the interior detailing. So until next time, which will probably be a week after next, we'll be rolling down the road.